Hey, my name is Darrell Fambro, and it's our third podcast involving continuity and using graphs to figure out whether a function is continuous or not. So the first question asks us to use the continuity checklist to determine if a function is continuous at x equals 2. So we know our continuity checklist is f of c exists the limit of f of x as x approaches c, and then f of c must equal the limit of f of x as x approaches c. So that is our continuity checklist. So now use the continuity checklist to determine the function if the function is continuous at x equals 2. So we look at 2 and we want to see whether it exists. So of course we see an open circle right here, but if you go up you see a closed circle. So f of 2, it does in fact exist. Now we look at our limit. The limit as x approaches 2 from the left is that number right there, and as it approaches from the right is up there. And we know that our fingers don't meet, so our limit does not exist. So the limit of f of x as x approaches 2 does not exist. So because f of 2 exists and the limit of f of x as x approaches 2 is not equal to that, the function is not continuous at x equals 2. And that is your first question.
Problem number 2 asks us to use the continuity checklist to determine if the function is continuous at x equals -4. So here we go to -4 and we see that it's an open dot. So that determines that that -4 does not exist. So at f of -4 Alright, on the second one, we gotta find if the limit of -4 exists or doesn't exist. Now we go to this point before -4 as x approaches -4, and it shows that it's an open dot, which means that it does exist. Alright, third, we see that f of -4 does not exist, and the limit of f of x as x approaches -4 does exist. And when those are two opposites and it does not exist and it does exist, that's how you know that the problem is not continuous. That's how you know that the line is not continuous. So you're right. So this says f of -4 is not continuous as the limit of f of x as x approaches -4.
Okay, question number 3 asks, does f of -1 exist? It's a pretty simple problem, so let's take a look at it. So we look at our graph, and we go to where x is -1. So let's start right there. So the question asks, does f of -1 exist? So an easy way to do that was just trace the graph, go up, and you see where -1 is, you hit this line right here. So, just to be safe, you can go over, and whatever value that is, which is probably around, let's say 1, 2, it's probably about 2.5, that lets you know that f of -1 exists. So that may be just an approximate, but to answer the question, does f of 1 exist?
Alright, number 4 asks us if the function is defined at x equal to -2. So we go to -2, and once I go up, I see we got an open circle and a closed circle. So I'm gonna go to the one that's on top of the closed circle. We go to the x, which is like 3.2. So the function is defined at x to negative 2 at 3.2.
Okay, so question number 5 asks to state how continuity and domain are related. So this is a pretty simple problem, so I erased the graph so we just, focus on the problem. So continuity is related to domain because if you get a function and it asks you to determine whether the function is a continuous set, all you really have to do is find a domain. So let's say we have a problem like, let's say we have 5x over the square root of 3x plus 2. Now, if a teacher or whatever worksheet asks you to do, if they ask you to find where this is continuous, then all you have to do is simply find a domain. So we know because there's a square root, you can't take the square root of a negative number that's greater than 0, and because the denominator it can't be 0. So what we do, 3x plus 2 is greater than 0. So that means 3x will be greater than negative 2, and x will be greater than negative 2 over 3. So if the problem asks you to find where the function is continuous on this graph, you would say the function is continuous when x is greater than negative 2 over 3. And that's how you know that continuity and domain are related, because all you did was find the domain in this problem. So that's it right there.
Alright, number 6 asks us to determine whether the function is continuous at f of x, 5x over square root of 8x subtract 2. And in this problem, I see it asking us to determine where the function is continuous, so that's basically just saying to find the domain. Right here in the denominator, I see that it's 8x, the square root of 8x, subtract 2. I automatically know that you cannot take the square root of a negative number, and 0 cannot be in the denominator. So that means you gotta bring the 8x, subtract 2. It's gonna be greater than 0. Right there. Now right here we're gonna take the square root of both sides. So 8x subtract 2. Square root it, and then 0. Right there. And that's gonna be 8x subtract 2 plus 2. Greater than 0 plus 2. Now that's going to drop 2. These are going to cancel out 2. And that's going to be plus 2. So 8x greater than 2. We're going to square root that. We're going to divide that by 8. Which is going to be x greater than 1 over 4. 8x greater than 2 over divided by 8 is equal to 8x greater than 1 over 4. That's the answer right here. Question: the function is continuous when 8x is greater than when x is greater than 1 over 4.
Okay, so question number 7 asks us to determine whether the function is continuous. So function is x minus 10 over x squared plus x minus 42. So looking at this problem, we already know that continuity is related to finding the domain of the problem, because when it asks you to find where a function is continuous, all you need to do is find the domain of the problem. So we see that this is x squared plus x minus 42. So we need two numbers to add together to get 1, and then multiply together to get number 42. So of course those numbers are negative 6 and 7. So this is also equal to, leave the numerator the way it is, we're not worried about that, but the bottom is x minus 6, x plus 7. And you multiply that, that gives you that right there. So now that we know that we need to find our domain, we have our denominator, we know that we can't have 0 in our denominator. So we're going to bring it back over here. X minus 6 cannot equal 0 because it's in the denominator. So x cannot equal 6. Then same thing for 7, x plus 7 cannot equal 0, x cannot equal negative 7. So another way of saying this is all real numbers except 6 and negative 7. But because the question asks us to determine whether the function is continuous or not, we will say that our function is continuous in all places except for when x is equal to 6 and for except when x is equal to -7. And that's how you do that problem.